Hello, your excellence, my channel's family. This is softwaring. Today I came back with another tutorial on how can you do harmonic analysis by using Ansysworkbench. So as you know the drill, the problem description is here. So as you see from the problem dimensional information used to create a cantilever beam is given, and also the geometrical in the loading conditions are given. So at the end what you have to do is just extracting or plotting the frequency difference of the z directional deformation. To start with, we have to open our Ansysworkbench. So as you know, Ansysworkbench harmonic analysis of Ansysworkbench requires model analysis as a prerequisite. So we have to open this model analysis first. Once the model analysis open, we just use a default material to the structural steel. So this structural steel is the default material for Ansys, and then we have to gain the geometry and we have to plot our beam. So millimeter is our unit in this problem. So let us select one plane and let us sketch our beam. Let us dimension it. The beam has 250 millimeter length and 10 millimeter height. Let us generate and extrude with 50 millimeter depth. So this is our beam. So we finished in the design modeler. So let us close it and proceed to the model stage. So double click on the model. It will open like this. So the Ansysworkbench interface seems like this. So let us accept the default mesh. Let us accept the default mesh. Generate the mesh. And then by clicking on the analysis setting, let us increase our number of modules. Let us extract the first 10 natural frequency of this system, and from this model insert fixed support at one end of the beam. Then after this, if we solve this, we will get the first 10 natural frequency of this system. So these are the first 10 natural frequency of the system. The minimum is 132 and the maximum is 6332. So now we can proceed to our harmonic analysis. So if we link the harmonic analysis with model analysis, all the data will transfer to the harmonic analysis from the model. So by double clicking on the setup, the Ansysworkbench will open like this. So from this harmonic analysis, we have to apply the load, harmonic force at the free end. Its magnitude is 1000 in the minus y direction. And from the analysis setting, let us adjust our frequency range from 132 to the maximum of like 5000 round. It must be below its maximum natural frequency. So from the solution, a frequency response, if you want to see the deformation, we can click here. So the geometry will be the face normal to y or z axis. So in this analysis, we get the deformation along the frequency response, or the frequency response, the displacement along the z direction. So if you solve this, we will get the result. So this is the phase angle versus the frequency, and the above one is amplitude versus the frequency. That means if you see on the model, so this deformation is along the z direction. So this is the result of frequency response plot, amplitude versus frequency with phase angle versus frequency, but this amplitude is in the z direction. So this is how can you do a harmonic analysis. There is a message here. So if you want to fix this message, you have to adjust on the settings. The maximum was 6332. So if you solve it again, we will get somewhat better result. So this is how can you do a response analysis. So if you want to see the response plot, you can press on the response frequency. So this is how can you do plot of frequency response deformation is the z direction. If you want to see the total deformation, the overall total deformation of the system, you can extract. And if you want to get the reaction force, you can, it requires boundary condition. So let us select fixed support. So if you solve it again, we will get the total reaction force and the total deformation. So the total deformation seems like this. So this is how can you do harmonic analysis. So this is what I have in this video. So thanks for watching.